Hello, Alg2 students. Mrs. Myers here. We are going to be taking a look today at tangent graphs and some transformations being applied to tangent graphs. Now, I hope that you have already watched the Screencastify video on how we get the tangent graph from the unit circle. If you have not done so yet, please pause watching this video and go and watch the Screencastify first and then come back to this, because I want to make sure that you understand where the tangent graph actually comes from. All right, so let's get started and put that tangent graph down here on the paper. We're just going to do one cycle worth. Okay, so we are going to just set ourselves up with some x and y axes, and again, from what we already just talked about, from what you just watched me talk to you about with the tangent graph, we are going to start right here at the origin. Okay, we're going to start at the point 0, 0, because at 0 radians, the tangent value is 0. And at pi over 2 radians, so there's a reason why I'm going to go 2 boxes. Okay, at pi over 2 radians, starting at 0 radians, there's going to be what we call an asymptote. Now, I'm going to draw this in as a dotted line, okay, just the way we did when we were doing exponential and logarithmic function graphs, okay, as we draw in our asymptotes as dotted lines. And as our radian measure goes from 0 to pi over 2, the tangent value just keeps increasing up, 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 up. But the thing is, there is a very special point that I mentioned to you in this first quadrant, and that is the point that is exactly halfway between, through the quadrant, which is at pi over 4 radians, okay, halfway from 0 to pi over 2 radians to pi over 4 radians, and it goes through exactly a y value of 1. Now, really, I didn't have to go only one box up to 1. I could have gone 2 boxes up to 1, doesn't matter, but that's extremely important that you realize, okay, that as our tangent graph is increasing, okay, through quadrant 1, okay, as the radian measure goes from 0 radians all the way to pi over 2 radians, and the tangent value just increases up, up, up forever and ever and ever towards infinity, that it does go through this very, very special point of positive 1. Now, as we continue to go through around the unit circle, when we go through quadrant 2, which means as we go from pi over 2 radians to pi radians, the tangent function still increases, but it doesn't increase from an actual value. It increases from what we have as negative infinity. Okay, so all the way down here, okay, at negative infinity is where the graph starts up, and it increases all the way as we go through quadrant 2 to where we eventually get right here at the point pi comma 0. Okay, so at pi radians, the tangent value is exactly 0. Now, as we're increasing from negative infinity, okay, all the way down here, just a smidge after pi over 2 radians, okay, all the way up to the point pi comma 0, we are going to pass through another very special point right here at 3 pi over 4 radians, and it's at a y value of -1, okay? So pretty much how we got this point right here to be exactly 1, because the unit circle had the point. Let me just quickly show you this right here, okay? So our unit circle, okay, as we're rotating around our unit circle. I didn't do a very good job showing the unit circle over here. Let me just fix that a tiny bit. Okay, so halfway through, we have the point right here, which is square root of 2 over 2, comma square root of 2 over 2, right? So that makes for that tangent value, okay, because remember tangent, okay, theta is equal to y over x, right? So when we do division of those two y and x coordinates, which are exactly the same, okay, right here at pi over 4 radians, okay, we'll rotate through pi over 4 radians, there's that point right there, okay? Now, over here in quadrant 2, this point right here that's exactly halfway through the coordinate, that's the same as what's over here, except it's negative radical 2 over 2, comma positive radical 2 over 2. So those two divide to be 1, but now they divide to be -1. So that's right here. Okay, so I'm going to increase all the way from negative infinity, right, up, 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 through this point right here, 3 pi over 4, comma -1, all the way to pi comma 0. And that, ladies and gentlemen, is what one cycle looks like. Okay? Now, we're not all the way through the unit circle. Okay, we're not. We're only halfway. All we did was go through quadrants 1 and 2. But the thing is to go through quadrants 3 and 4, which is produce exactly the exact same graph. Like if we just copy and paste that right here to go from pi radians to 3 pi over 2 radians all the way to 2 pi radians, we would just have exactly that same looking graph, which means we would just have a second cycle. So something very, very important here happens at the tangent graph, and that is that we have a standard period, okay, of not 2 pi radians like with sine and cosine, but only pi radians, okay? Very, very, very important, okay? That your standard period is only pi radians and that you know exactly what one cycle looks like, okay, for one period right there. Now, there's still 4 equal parts, right? See that? This is 1 part, 2 parts, 3 parts, 4 parts, okay? So there's still 4 equal parts that we're going to take that period and we're going to divide it into, okay? That one cycle is going to be divided into 4 equal parts, except we just didn't need to go all the way around the unit circle to do it, okay? So now let's apply some transformations. Okay. So as always, we always do dilations, then reflections, then translations. Well, today we're only going to do dilations and reflections. Okay, we're going to save translations for the next day. So we're going to start off with our first example being y is equal to 3 tan 2x. All right, so what we know from before is that anytime we have multiplication, okay, we are going to do a dilation, okay? And I vote, right? Whenever the operation's inside, it means it's a horizontal transformation. Whenever it's outside, it's vertical, okay? So this 3 that we're multiplying right here, that is going to be affecting the y's. That's going to be a vertical dilation, okay? And that multiplier is exactly that scale factor, and it's going to vertically stretch the graph, right? So it's going to vertically stretch that graph. Now here, there's multiplication by 2, which is inside. That is a horizontal dilation, so it's going to affect the x's. And that multiplier needs to be reciprocated, okay, right here to see what our scale factor is. So this is actually going to be a horizontal compression. So we're going to take this and we're going to compress it down, okay? So let's see what the graph looks like. And okay, I'm going to just ask us for this particular problem, okay, to sketch 2 cycles. Okay, so if we take a look here, okay, to get 2 cycles worth, okay, just getting my x's all set up, x and y for the labels, right? We are still going to have 1, 2, 3, 4 equal intervals to make up the cycle, okay? And this is what the cycle looks like. So we start at what we call a midline point, okay? So that's going to be right there at 0, 0, okay? And then after 2 equal intervals worth, we're going to have our asymptote, okay? And then at 2 more equal intervals, we're going to end at another midline point, okay? So that's really nice. Now, those midline points will be right there on the x-axis as long as we don't do any vertical shifting, okay? Any vertical translations, moving the graph up or down, which we're not, okay? We're not doing any translations here today at all. So the dilation, okay, whether it's the vertical or horizontal dilation, those don't change, okay? You start your cycle right there at 0, 0, and then you end your cycle right there at another midline point where the y value is still a 0. But what you are going to change, okay, one is you're going to change this period, okay? You're going to change how many radians it takes to finish up that cycle, okay? Instead of your standard period, okay, again for sine and cosine, which was 2 pi, instead of that standard period being 2 pi for sine and cosine, for tangent it's only pi. But because I'm horizontally compressing this by a scale factor of 1/2, that is now a period of only pi over 2 radians, okay? So all the way, okay, there. My whole cycle is not going to need to go from 0 to pi to be completed. It's only going to need to go from 0 to pi over 2 to be completed. So what does that mean about my scale, right? So I still take my period and divide it by 4. It's all 4 equal intervals, okay? I am going to take that pi over 2 and I'm going to multiply it by 1/4, okay, because that's what dividing by 4 is the same as, so it's going to be pi over 8. So now I know that every box here is pi over 8, so 0, pi over 8, so it's 1 pi over 8. This is 2 pi over 8, which reduces to pi over 4, and this is 3 pi over 8, and this would be 4 pi over 8, which reduces to pi over 2, so that's nice. Now, let's take a look at this vertical dilation, okay? So how I'm going to show that I'm vertically stretching my graph by a scale factor of 3, okay, is going to be a little bit different for tangent. See, I don't have an amplitude with tangent the way I do with sine and cosine. I don't have a maximum point and a minimum point the way I did with sine and cosine because I've got this asymptote here with tangent. My graph just goes up forever and ever and ever to positive infinity. So how do you show that it's going to be 3 times steeper, than it was before, right? You don't have a maximum to show that. It's going to go like instead of to 1, it's going to go to 3. But what you use is this point right here. Okay, you see halfway from this midline point to the asymptote, I go through this y value of 1 right here. Well, what's going on now is halfway between the midline and this asymptote right here, which happens to be at pi over 8 radians now, I'm going to go through a y value of 3. Okay, so instead of having this y value only be 1 halfway between the midline and the asymptote, now it's at 3. And there, oops, I didn't really give myself a lot of room. And that's how we show that. See how that's much steeper that is than what this was before? And likewise, okay, halfway between the asymptote and the midline point that finishes a cycle, instead of it being down at -1, now instead it's going to be down here at -3. And then I just increase like this. There we go. Okay, so I go from -infinity through this point right here, 3 pi over 8 -3, all the way up to pi over 2 comma 0. And that is what one cycle looks like. Now, I've asked you, though, to show me 2 cycles. So here's how I could show 2 cycles, is I could just go in the positive x direction, and I could just copy and paste this, which means that this midline point right here that ends this cycle, just think of it as this midline point that starts it, right? So this piece right here, I just want to mimic that right here. So I'm going to go one more box later up to y value 3, and then one more box after that is going to be this asymptote, okay? And then the graph just goes up from positive infinity. See how I just mimic that right in there, okay? And then likewise, okay, see one box after the asymptote gets me down at that y value of -3. That's what I'm going to do right there. Go down to y -3. And then right here, I'm going to finish at a midline point. And there you go. That would be 2 cycles worth. Now, we got to finish this radian measure. So what's my scaling, right? It's pi over 8. Okay, my scaling is pi over 8. So I go 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, right? I've reduced this. Okay, 4 pi over 8 reduced, but it was 4 pi over 8. So now this is 5 pi over 8, 6 pi over 8 reduces, and I've got 7 pi over 8, and then I've got 8 pi over 8, which is pi. Now that's good. That's perfect. So because if I have one cycle that ends at pi over 2, then I would have a second cycle that ends at pi radians. And there we go. That's what that graph looks like. Okay? I absolutely could have done another cycle if I continued here in the negative x direction. In fact, let me show you what that looks like. Okay? So I would have 2 boxes in would be an asymptote here. Okay? And then 2 more boxes to the left would be my midline point. So I'm just going to take this graph and I'm just going to copy and paste it over here. So now, see, this midline point is right here. So as I'm going left, I got to think, well, what happened here? I went down, right, through that y value of -3. Right there. See? So that piece mimics this one, right, because I'm copying and pasting this whole section over to here. And then this piece right in here would get copied and pasted over to there. Okay? So now what I've shown you is 3 cycles, right? So this right here from 0 to pi over 2, okay, that is a cycle. That's one cycle. And then from pi over 2 to pi, right, that's another cycle. And then from, let's look at these radian measures. See, every pi over 8 radians for every box. This would be -1 pi over 8, -2 pi over 8 reduced, -3 pi over 8, -4 pi over 8 reduced. See, that's -pi over 2. This right here, okay, this would be another cycle. All right, so that's what that all looks like. All right, let's take a look at one more, and this time we're going to do y equals -tan of 3x. All right, so I only have 2 transformations to worry about here. I don't have a vertical dilation because this is really like the number 1, like what I started with right there. Okay, this is what just plain old y equals tan x looks like. Okay, I am going to have, though, a dilation of 1/3 to the x's, right, because there's this multiplier of 3, which means my scale factor is 1/3 and it's inside, so it's with respect to the x's, okay? So that's going to change the period of the graph, so let's go ahead and write that up. So the period would be a standard pi radians if I wasn't doing that horizontal dilation. Okay, remember we talked about how that standard period's not 2 pi anymore like sine and cosine, it's pi, but I am multiplying it by a scale factor of 1/3. I'm horizontally compressing this down, so now it's a period of only pi over 3. Okay, and then what that's going to make the scale be, okay, is that pi over 3 divided by 4. Okay, 4 equal parts, which means pi over 3 times 1/4, and that's going to get me to pi over 12. All right, but now I got one more thing. See that negation? That's going to be a reflection. And since that's outside, that's going to be vertical, and it's going to go over the x-axis. So I'm going to do this as two separate graphs right here for you. First, I want to show you, okay, what it would look like to only have the dilation done along the x-axis, okay? So I'm just going to have this y value still be 1 and -1, like in the parent graph, because I'm not doing a vertical dilation at all. I'm going to go 4 equal boxes to make one cycle starting at 0, and I know that that is now going to be a period of pi over 3. See, I'm going to put that as pi over 3 now, because that's my horizontal dilation is changing the period. And I'm going to start at my midline, okay? And one more box in, I'm going to get to the y value of 1. One more box in is going to bring me to my asymptote, and I just increase right through that, okay? And then one box in is going to be down at -1. One more box is going to end at the midline point, and then I'll increase from there, okay? So that's what one cycle looks like. Now, this pi over 3 radians, again, is what completes the cycle, and that means that I have a scaling of pi over 12, because I divide that into 4 equal intervals. So if this is 0, this is 1 pi over 12. It's going to be 2 pi over 12, or pi over 6. It's going to be 3 pi over 12, and that would reduce down to pi over 4. And then that would be 4 pi over 12, and that would reduce down to pi over 3. So that's what the one cycle would look like with the dilation. Now what I got to do, I'm going to do this on another cycle right here, another sketch, because I don't want this to be too tricky otherwise, is I'm going to show what it looks like to do the reflection on a separate graph, okay? Now, because I want us to do some sketching over an interval, I'll give you that interval in just a minute, okay? I'm going to go left and right quite a bit here, okay? All right, so anyway, I'm still going to have those y values of 1 and -1, okay? I'm still going to have my cycle go from 0 to 1 pi over 12, 2 pi over 12, which is pi over 6, 3 pi over 12, which is pi over 4, 4 pi over 12, which finishes at pi over 3, right? My period is pi over 3. But now this is going to be reflected over the x-axis. So instead of the graph increasing to positive infinity and going through pi over 12 comma 1, it's going to decrease down to negative infinity. It's going to go through pi over 12 comma -1. All right, I'm still going to have this asymptote, but now the graph is going to decrease down to negative infinity instead. Right, see, I'm just going to like basically go upside down with that. I'm going to just flip that over the x-axis. So instead of it increasing, it's going to decrease. And this piece where it was increasing and went through the point pi over 4 comma -1, now it's going to be decreasing, and it's going to go through pi over 4 comma +1. Okay, I'm still going to have pi over 3 comma 0. That right in there. Okay, that's what that graph's going to look like when it's reflected over the x-axis. Okay, so this is what my final cycle looks like, but I'm not done with the graph because I would like you to sketch, oops, can't spell right there, sketch, okay, in the interval, okay, and it sets up like this, okay, so it's going to set up as pi as the boundary here, and then negative pi over 3 here. So I can see that I am not quite at pi radians here, I'm only at pi over 3. Well, if I have one cycle going to pi over 3, what does that mean about my second cycle? So 4 more boxes later, okay, if this is at 1 pi over 3, this would be at 2 pi over 3, okay? And in order to get to pi, well, what I just have to do another pi over 3. So let me just erase this here. that would just have me go 1, 2, 3, 4 more boxes right there. And that would get me to pi radians. Now, on the other end going to the left, I want to get to negative pi over 3. Well, if one cycle going off to the right is positive pi over 3, and one cycle going off to the left is negative pi over 3, okay? And I just got to put my scaling in. So this is pi over 12, right? So it's 1 pi over 12, 2 pi over 12 it reduced, 3 pi over 12 it reduced, 4 pi over 12. So now this is going to be 5 pi over 12, okay? This will be 6 pi over 12 and it's going to reduce, 7 pi over 12, 8 pi over 12 would reduce, 9 pi over 12, that would reduce, 10 pi over 12 would reduce, 11 pi over 12, and that would be 12 pi over 12 and it's pi radians. And then over here, this is going to be negative 1 pi over 12, negative 2 pi over 12, it reduces, negative 3 pi over 12, which would reduce, and then of course negative 4 pi over 12. And then I just want to get this continued. So you see how this goes down, then down, and I always go through those points right there at negative 1, then positive 1. So this point would be here. Here's my asymptote, and it would go down to negative infinity. And then I would have this point right here, that point mimicked over there, and I would go down to negative infinity. So there we go. See, I'd have a second cycle in there, and then I would copy and paste that again. So this would go down all the way through that point right there, going to negative infinity. And then here, I would come through this point right here, down to there, and I would go all the way down. I would go from increasing from positive infinity through that point all the way down there. And then over here on the negative x-axis part, okay, I would have this point at negative pi over 12 comma 1, and then I would have my asymptote right here at pi or negative pi over 6, my vertical asymptote, and I would decrease down like that. Okay, so that piece would mimic over there. And then last but not least, this piece right in here would be mimicked here. So I'd have that point of negative pi over 3 comma 0. I'd go down here negative pi over 4, negative 1. And then I would decrease down to negative infinity. So this is what the final graph would look like right here, having done the horizontal dilation, which changed the period and the scaling along the x-axis, okay? I don't have a vertical dilation, so that's why I just had that 1 and negative 1 value on my y-axis, and then I reflected over the x-axis. But when I'm asked to sketch within an interval, I make sure that I am extending as far left as what this radian measure shows, see negative pi over 3, and I'm extending as far right as what this radian measure showed, see all the way over here to pi radians, and you always make sure that you have your x-axis fully scaled for all those critical points in the graph, and then you always make sure that you have your y-axis scaled. All right, so I hope that you have a good understanding of what tangent graphing looks like with respect to dilations and reflections, and in the next video we'll do translations. All right, so you've got a couple of problems to try with respect to this for tonight, and let me know if you have any difficulties. Bye-bye.